Okay, hello everyone. Welcoming you all in our 3-day long training session workshop on spatial analysis and mapping using SuperMap. Today is the third and the last day of our training session, and hope you all enjoyed the earlier sessions. And today is our third day of this workshop. So let's move on to our content. This is the content for our 3-day training session, and we covered every single part of this content last 2 days. And today we will see how the 3D data in SuperMap works with its platform. So the content for today is the organization and application of 3D data, models in 3D scene, and then we will take a little break. After that, we will move forward with our 3D analysis. Okay. So first of all, let's move on to our first content, that the organization and application of 3D data. Okay. So I'm again welcoming you all. I'm Waidur Rahman, Technical Support Engineer from SuperMap Asia and Oceania Center. And if you have any questions, any queries regarding the any part of this training, you can ask me in the Q&A session. And yes, of course, you can write your question also in the chat box, but it's better to ask me in Q&A section of Zoom. Okay. So let's move on to our training today. So here you can see that we will continue our training. Like, this is the overview for our first part of 3D data structure. So first of all, we will see how the data structure works. Then we will see the 3D scene introduction, the browsing 3D scene, 3D layer organization, 3D flying, and also the applications. Okay. So here you can see the total data structure of 3D analysis in SuperMap. First of all, that we work with the workspace in SuperMap platform, as you can incorporate the dataset from your file dataset or your database. You can use the SuperMap UDB or UDBX file format for your data source, or you can use any like SQL Server, Oracle, something like that in your workspace. Okay. And the file types is like the workspace file is SMW or SXW, and the database types is SQL Server or Oracle. And the data sets from this file and file workspace is stored in a data source, and you can add all of them to any scene layer. So a scene layer is basically divided into 3 layers, like screen layer, general layer, and terrain layer. So after that, you can also add all of the resources here from the marker symbol library, line symbol library, and field symbol library. Okay, so here you can see that the 3D scene introduction. Actually, the 3D scene uses virtualized technology to simulate various geographic features and their spatial relationship in the real world. And there are mainly two view mode of 3D scene. First of all, plane scene and a spherical scene. Okay, this is the plane scene. It's the surface of the earth is spread out into a plane to load and display features. Okay, and it uses the planar coordinate system data and projected coordinate system data. And to display the ocean, atmosphere, and critical level, it's actually not supported in plane scene. You can visualize them in your spherical scene. Okay, and this is the spherical scene. The spherical scene simulates the surface of the earth within a sphere. Okay. So browsing 3D scene that uses you can use the compass, keyboard, or your mouse, and you can control the display scene elements, every single elements. You can browse features, properties. You can measure the scene. Actually, you can measure the distance, area, angle, and so on. Okay. So a 3D scene actually, the organization, a 3D scene actually based on three different layers. First of all, the top layer is, we call them as scene layer. The scene layer is actually like the static graphics, such as any logo or any description or any text in your scene that you want to show. And then the second layer is general layer. So the general layer uses the 2D data, 3D data, cache data, service layer, and also the KML layer. You can add all of them in a single general layer. And then you have the bottom layer is terrain layer. In terrain layer, you can add digital elevation model, grid, and also the terrain cache. So here you can see that the scene layer, you can add the scene layer as like watermark, any logo or any level, etc. And here it supports like PNG, JPG, JPEG, BNP, this type of images actually. And it uses the screen coordinates. Okay, so there have no geographic meaning. There have static relative to 3D window. And exercise, we will go for an exercise in our software for how to add your static 3D static screen layer as like SuperMap logo. And there have like adding general like model. You can add map, model, OSGB cache, image dataset, KML file, and so on. Okay, these are the as you can add. And adding terrain layer, you can add like grid or terrain cache. Okay, and there have options for 3D spatial analysis. First of all, you can add like these are the multi-terminal application of 3D data using the WebGL, mobile, virtual reality, augmented reality, and so on. Okay, so we are moving to our software. Okay, back to again in our regular. Okay. Okay, thank you everyone. So this is our iDesktop X. I'm using the iDesktop X, and for your friends, I am using another one. Like, okay. So here you can see this is a iDesktop X interface, and yes, 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 you all know the interface very well, as you already, I hope you already downloaded the software and installed in your PC, and hope you can run all of the tasks in your PC. Okay, so first of all, I'm opening a data set from here. Okay, so these are the data set like 3D cache scene, like 3D scene, OSGB file, terrain, and KML files. Okay, so first of all, I'm opening a 3D scene from here, like this 3D scene.smwu workspace, and I'm opening in my iDesktop X. So here is two different platform opened. Here I'm closing one. Okay, here you can see that the 3D scene layers added, and this is our scene layer. Okay. So if I just here you can see that our scene layers are added here, and these are our spherical 3D scene, and there have a lot of data set incorporated in these 3D scenes. So I'm opening one scene here. Okay. So here you can see I opened my 3D scene. This is a city of China. This is totally a 3D, 3-dimension dataset. So you can see there. This is our 3D data in SuperMap IDX. You can see every detail of the dataset. Okay. So if I zoom in any part of the data, so you can see that you can browse in every single part like this. Okay, you can see the underground of this road, of this flyover. So you can see the interactive 3D data in SuperMap. Okay, so if I just go to normal layer, okay, just zooming into the full extent, right click here and refreshing. And if I want to full extend the layer, like from here, ground CVD, like zoom to layer, it will automatically zoom your full extent. Okay, so here we see that there have 3 types of layer, like screen layer, normal layer. Normal layer are like these data sets, all of the data set, and also the terrain layer. So we will add our SuperMap logo as a scene layer, to visualize the logo in our 3D scene. Okay. So this is our 3D scene. Okay, now I'm going to add a scene layer, just right click here, this scene layer, and you can see that add object button is available. Just I'm adding my object, add object. And then I'm adding like SuperMap logo. Okay, supermap.png. And then here you can see that SuperMap logo is now in here. And I want to edit this logo and want to fix this position of this logo. And just right click here and select edit. And here you can see that the pointer you can add here, and you can move the logo anywhere you want. Okay, so I want to move the logo in my this corner. Okay, done. So I just closing the edit button, and now you can see that the logo is now seen in our, like if I want to zoom the layer, now logo is visible in this corner. So this logo is in our scene layer and the normal layer containing all of this data set. So this is the example for adding any of the scene layer here. Okay, so I hope you all got this idea, and if you have any question you can ask in the chat box or Q&A session. Okay, let's move on to our next part, that is models in 3D scene. Okay, so the models in our 3D scene, this is the overview that containing that the 3D symbolization, rapid modeling by vector stretching, 3ds max model, animation model, oblique photographic model, and beam model. So you can all of this in a single platform of SuperMap. Yes. Yeah. There's the training session running. With, yes. Okay, so let's move on. So this is the example for the 3D symbolization, that the vector rendering. It's actually the 3D symbolization of point, line, and polygon data. Here you can see, you can symbolize a 2D point, like you have the data set for any tree data set or any types of point data set. Then you can symbolize the 2D point in your 3D scene. And you can symbolize like 2D line, symbolizing the 2D polygon also. So like we'll not we'll see all of the things that how to prepare these models. This is the example for the animation model. Like you can add all of them in your SuperMap. So I'm now moving forward directly to our demonstration part, actually the 3D analysis. Okay. So SuperMap 3D analysis. We will demonstrate like see the how isoline analysis works, slope and aspect analysis, flood analysis, visibility analysis, view shed analysis, sunlight analysis, profile analysis, skyline analysis, etc. And the isoline analysis, like isoline is the mostly commonly used method to represent a surface on a map. It's the line of the control point of a digital elevation model. Okay. Slope and aspect analysis. Slope is actually the gradient or steepness of a unit of terrain, and this aspect identifies the downslope direction of the maximum rate of change in value from each cell to its neighbor actually. And here you can see the flooding analysis. This is the simulation. It actually uses to simulate the flooding process over a duration of time with the specified speed and within the maximum or minimum elevation. The visibility analysis, it's actually often used 3D analysis. This function is used to determine whether certain location in a 3D scene are visible to the observer location. And the viewshed analysis, this function is used to identify all the visible and invisible ranges in an analysis area of a scene. And the sunlight analysis here. This analysis is used to calculate the duration of sunlight in a period of time within an extent defined by the longitude and latitude. Profile analysis. The profile actually shows the change of elevation along the line. We will demonstrate them to show you how this works in SuperMap. And this is the skyline analysis. This function actually allow you to generate of the boundary between the building tops and the sky from an observer point. Okay, so let's move on to our demonstration part. Three D analysis. Okay, so this is the workspace manager, and I'm closing all of the workspace. Okay, and opening my 3D analysis dataset in iDesktop X. So here you can see we have one scene layer, like this 3D analysis layer. And I'm just opening the scene. This is for our 3D analysis dataset. Now I will demonstrate some of the 3D analysis using this 3D dataset or 3D model. Okay. Okay, so first of all, here you can see we have number of 3D analysis available here. Okay, so if I mark all of them, that you have this, all of this 3D spatial analysis. You can do like slope and aspect analysis, isoline analysis, flooding analysis, or visibility analysis, view shed analysis, openness analysis, sunlight analysis, profile analysis, video projection, skyline analysis, cut and fill analysis. Okay, so you can do all of the things using your dataset, using your 3D dataset. So first of all, what will we do with this dataset? This is our 3D model dataset, and we will see the visibility, view shed, and sunlight analysis using this dataset. Okay, so let's move on for our first one, like we want to see the visibility analysis from this building, and this will be our field of view. Okay, so let's select this analysis. Okay, and here 3D spatial analysis panel will appear, and you can see you can control all of the things by using this panel actually. So I'm selecting the visibility analysis from here, and this is to select my point or add my point to show or see how the visibility analysis works. So I'm selecting this add button, and I'm selecting a point from this building actually, from this point. Okay, so now here you can see that whenever I am drawing a line, okay, I'm closing line here, here, here. So and just right click when you want to finish this. Okay, so here you can see that the analysis is showing two types of line. Okay, and from this point we have this green line and also the red line, and the green line showing that you can all of the points from this point, this starting point, the green lines area are visible from this point, and this red portion of this line are not visible from this point. Okay, so here you can see from this point. Okay, this is actually the visibility analysis done. And the next one we will see how the like view shed analysis works. This one is view shed analysis, and it's actually view shed analysis in 3D scene. And if I select the view shed analysis, and if I select a point from here, like link plus button and a point, and just going to this area. Okay, whenever you complete, just right click, and you can see that the view from this point, this is our starting point, and the view from this point are these areas. Like you can see that the green areas are views are visible from this point, and the red area are not visible. Okay, so this is the example for the view shed analysis in SuperMap platform. Okay, and then we will see the sunlight analysis in our a specific portion of this dataset. So if I go to the like this area, and I want to see how much sunlight grabs this area actually. Okay, and their time. So I'm selecting the sunlight analysis from here, and I need to select the area, like from here to here to here to here, and I've completed. Just right click here, and it will automatically calculate all of the portion of sunlight available for this area. Okay, so here you can see the sunlight area is showing here that the sunlight analysis. Okay, so here you can see that the sunlight analysis are here, and you can change the color from here. Okay, if I select this one, you can see you can change the color for this sunlight analysis. and every point here will have you can just click on this point. Okay, if I select this selection button, there is time interval. You can change the time interval like 30, and you also can change the starting time and ending time from here. Okay. So if I want to see the sunlight from 9 a.m. to 2 p.m. of today, okay, and end time is 30. Now you can see the result. You can also change the color. So minimum height and maximum height, you can change the maximum height like 100. Okay, so this is actually the example for the sunlight analysis in SuperMap, and we will go for the Skyline analysis also in for this data set. We'll see the skyline for this portion. Here you can see. Okay, so the skyline analysis here, you can see this will create a building height, and just I'm going to a skyline from here, or profile analysis. You can just need to draw a line, and this is the profile of this line. Okay, this is the profile information, and here you can see the altitude from here. This is the 0 point, and this is the altitude of these buildings. This is actually the profile analysis. So all of this analysis incorporated in 3D analysis menu in SuperMap. You can try all of them. Okay, so I'm closing this one. If you have any question regarding this, you can ask. I don't need to save this. Okay, so now what I will do, I will show you how other 3D analysis works. Like I'm adding a 3D model, or like this is a digital elevation model actually. This is a DM data, and here you can see the DM model of 3D model of digital elevation here. And what will you do? You will see how this like slope and aspect analysis works, and also the isoline analysis. Okay, so I'm selecting the slope and aspect analysis from here, and I want to see the slope and aspect of a specified region from this digital elevation model. So I'm adding my region here. Okay, I'm just drawing like, okay, so here you can see that the slope and aspect, and also you can show only slope or only aspect from here, or you can show the both of them on aspect and slope, and also you can show the like slope and aspect query from here. and you can change the color. Okay, so here you can see that I've changed my color of slope and aspect analysis here, and again, what can you do? You can click on this flow button to see the direction of slope using the aspect result. So if I see edit this flow button, here you can see the flowing of 3D points along with their direction of slope showing in our 3D slope and aspect analysis. So this is too much interactive and very much ready to use tool sets in SuperMap. Okay. So I highly recommend all of you to install SuperMap in your PC and try all of these functionalities. Okay. So now we will go for our another analysis like Isoline analysis. Let's see how the Isoline analysis works. And okay, the Isoline analysis here. I want to see the isoline of this region actually, of this area. Okay, so I am adding my region from here. Like, so here you can see the real-time isoline analysis of our 3D data showing here. Just right click whenever you finish. So here you can see that the isolines or contour lines of this data set showing. Okay, and you can change all of the properties from here. You can change all of the properties, like all of them. Sorry. Okay, so here you can see the interval. If I change the interval like 100, and you can see the automatic adding or decreasing of interval here. If I want to interval like 200, and here you can see the automatic application of this interval. If I interval like 50, and then I can see again. So I want to interval like 90, and I want to change the line color, like I want to change it like black, like blackish type, and I want to change the texture color table like this one. Okay, so now here you can see the isoline analysis of our 3D data, actually the 3D digital elevation model showing in our map. Okay, this is too much interesting, right? Okay, so these are the like lower altitude area, and here you can see the watercolor here, and these are the hilly areas. These are the valleys actually. Okay, so these were the example for the isoline analysis in theory, and you can apply all of them. You can apply like you can use the OSGB dataset and your own dataset in your SuperMap platform. It's very easy and very user friendly. Okay, I hope you all enjoyed this, and I'm going to my Q&A session for today. Hello, I have a question about the import of database KML or UZZ. Could you please clarify this point? Yes, you can add the KML dataset. Like I want to add one dataset in my like CVD. Okay, so I just need to go to the import dataset. Right click here, import dataset, and add file. And you can add, like here you can see the Google KML file available here. So if you want to add any KML file or any other file, you can just select this KML and select your KML file from your dataset. Okay. and just select your KML file and just open it in your data source. It's too much easy. Okay. Hello, Roman. Thanks for the making acknowledge emerging knowledge impression for the first 3 days on SuperMap. Please, yes, you all will get the recording for of this 3 days training session in your email within tomorrow, and also you will get them in our YouTube channel, official YouTube channel of SuperMap. And thank you so much, everyone. Again, thank you so much, everyone. Again, for your patience and joining this 3-day long workshop on spatial analysis and mapping using SuperMap. And we are looking for distributor, partner, and also the clients for our SuperMap. And if you have any queries and if you want to contact us, like, I'm going to share. Yes, you can contact us via supermap bangladesh@gmail.com or global@supermap.com. Okay, so I hope you all enjoyed all of the things, and thank you all again for joining our training sessions.